Before moving to NLP concept, if you have not watched my previous deep learning video where I have covered tokenization, attention mechanism, embeddings, transformers, please go through it, and rest of the concept I will be covering in this video. What is NLP? Natural language processing is a branch of AI which enables computers to understand, process, and generate human language. It acts as a bridge between human language and AI models. Whenever you use ChatGPT, Google Translate, Grammarly, Siri, Alexa, all are using NLP. Before training AI models, text usually needs pre-processing, like removing HTML tags, removing unnecessary punctuations, converting text into lower cases whenever it is required, removing duplicate spaces, handling special characters, correcting formatting issues. In the real world system, imagine an e-commerce company having millions of customer reviews, and without pre-processing, the same word may appear many inconsistent form, making training less effective. Some words appear very frequently but often add little meaning for certain NLP tasks. For example, the, is, are, was, and. These are all called stop words. In real world system, when searching a document, a system may ignore these stop words to retrieve results faster and more accurately. But modern LLMs like ChatGPT, they do not remove stop words. Even the common words contribute for the context and meaning. Different forms of the same word should often be treated as the same concept. For example, running, runs, runner, run. Stemming cuts words to their root form, sometimes producing non-dictionary words. Example, running to run and studies to study. Lemmatization uses language rules to convert words into their proper base form. For example, running to run and better to good. In real-world systems, search engines use these techniques so that searching for running shoes can also find results containing run. Part of speech tagging, POS tagging, identifies the grammatical role of each word. For example, the cat runs quickly. Model identifies the determiner cat as a noun, runs as a verb, and quickly as adverb. In the real world system, grammar checking tools like Grammarly rely on POS tagging to understand sentence structure. Named entity recognition, NER identifies important entities within text. For example, it includes person, organization, location, date, currency. Take an example, Vinaya visited Bengaluru yesterday. NER identifies Vinaya as a person, Bengaluru as a location, and yesterday as a data time. In real-world systems, banks automatically extracts names, account numbers, dates, and organizations from documents using NER. Sentiment analysis determines whether text express positive, negative, or neutral. Let's consider a sentence. The mobile is fantastic. It is positive. This laptop keeps crashing. It's negative. In real world, companies analyze thousands of apps review and social media posts to analyze customer satisfaction. In text classification, the goal is to assign text to predefined categories. For example, an email having subject, congratulations, you won 10 lakhs. It has to go to spam. There is another email with subject, meeting at 2 p.m. It has to go to inbox. In the real world example, Gmail spam detection is one of the most common text classification system. Machine translator automatically translate one language into another. For example, in English, how are you? In Kannada, ನೀವು ಹೇಗಿದ್ದೀರಿ? In real world, Google Translate and Microsoft Translator uses this technology. Text summarization converts long document into a shorter version while preserving the important information. In real world example, ChatGPT summarizes PDFs, meeting notes, research papers, legal documents, medical reports. In information retrieval, instead of generating answers, NLP system retrieves the most relevant document. This is especially important in enterprise AI. In real world example, when you ask, what is our company leave policy? A rack system first retrieves the relevant HR document before an LLM generates the answers. This is why information retrieval remains one of the most important NLP concept for GenAI engineer. Although today's LLMs are powered by transformers, traditional NLP concepts are still used in production system. A GenAI engineer doesn't just work with LLMs, they also build systems that process text, extract entities, classify documents, retrieve knowledge, and analyze customer feedback. So, understanding these NLP fundamentals will help you design more accurate, reliable, and scalable AI applications.